Welcome back, guys. Hope all is well. And now we're going to talk about what is called the correlation coefficient. And you will definitely be seeing this in Stats 250 and in any higher level stats classes that you take. This is very essential, especially if you are going for your master's degree or a PhD. But we're going to look at it on its lowest level and make some interpretations and observations. Now, the correlation coefficient. Statisticians use a measure called the correlation coefficient to determine the strength of a linear relationship between two variables. There are several types of correlation coefficients. The most famous one that we're going to use is what is called the Pearson's product moment correlation, PPMC. And that is named after the statistician of Carl Pearson. Let's talk about linear correlation. The range of the linear correlation coefficient is from -1 to +1. If there is a strong positive linear relationship between the variables, the value of R will be close to +1. So, the stronger the relationship is in the positive direction, the closer the correlation coefficient will be to +1. If there is a strong negative linear relationship between the variables, the value of the correlation coefficient, which is R, will be close to -1. The stronger the relationship in the negative direction means the closer R will be to -1. And last, but certainly not least, when there is no relationship between the variables or only a weak relationship, whether it's weak positive or weak negative, the value of R will be close to 0. 0 indicating that there is no relationship between the variables. To compute the correlation coefficient by hand, we will be using this formula right here. Now, this formula may look overwhelming when you see it at first, but two things that I want to state. Number one, you will not be asked to do this on Alex. Number two, I highly doubt you'll be doing this on the final exam for this class. But I want to introduce to you how we find the correlation coefficient, especially since you're going to be doing it in Statistics 250. Now, let's do number 2. Compute the correlation coefficient for question 1. Determine the strength and the direction. Back in question 1, we was able to determine the direction of the relationship. It is negative because as our X increases, the values of Y will decrease. Now let's determine how strong that relationship is in the negative direction. Now, we see a lot of sums of X's and Y's. We see an X squared and a Y squared as well. Let's keep that in mind. And also we see the letter N. Now remember, N equals sample size. My sample size in this case is going to be 7. It is 7 because we have a total of 7 students. Student A to student G. Now we need to find the rest. So what you need to do is create additional columns. Okay. Now, if you notice, I created a column for X times Y, an X squared, and a Y squared column. And I want to do these in different colors. Let's do X times Y in light blue. To find X times Y, we multiply the X's and the Y's. To find X squared, we are just squaring the values of X. And then to find Y squared, we are squaring the values of Y. The reason why we need these other columns is because if you look in our correlation coefficient formula, we need to find the sum of x, the sum of y. We need to find the sum of x times y. We need to find the sum of the squares of x. And we need to find the sum of the squares for y. Excuse my sigmas. I can't draw them too good. That is why we need these columns. Let's first find the sums of x and the sums of y. To find that, let's just add up all the x values and all the y values. So add up the x's, 6 plus 2 plus 15 plus 9 plus 12, 5 plus 8. That equals 57. And after that, I'm going to show you how to do it in the calculator. Now let's find the sum of y. 80 plus 99 plus 43 plus 60 plus 58 plus 77 plus 78. Let me double check that to make sure I did this correctly. 80 plus 99 plus 43 plus 60 plus 58 plus 77 plus 78. That is 495. Okay. Let's make this calculator a little bit smaller. Now, let's find the sum of x times y, which means I must multiply all the x's and y's first. So 6 times 80 is 480. 2 times 99 is 198. 15 times 43, that is 645. 9 times 60 is 540. 12 times 58 is 696. 5 times 77, 385. And 8 times 78 is 624. Now, what I'm going to do is I'm going to find the sums at the end. I now want to find my x squared, so I can find the sum of the square of x. Basically, we're just going to square all the x values. Let's move this out the way. So x is 6 right here. So 6 squared will equal to 36. X is 2. So 2 squared is 4. X is 15. 15 squared is 225. 9 squared is 81. 12 squared is 144. 5 squared is 25. 8 squared is 64. Now, let's find y squareds. 80 squared is 6,400. 99 squared is going to be 9,801. 43 squared is going to be 1,849. 60 squared is 3,600. And just to double check, let me do 43 squared in my calculator. I'm pretty sure that I'm correct, but I just want to make sure. Okay, that's good. Anyways, let's continue. 58 squared. Let's do that in a calculator just to make sure that I'm getting it correctly. 3,364. 77 squared. Oops, let me erase that. My apologies, clear that. 77 squared. That is 5,929. And 78 squared is 6,084. Okay. After you do that, find the sums for each of those columns. So let's clear this. So that's 480. 3568. Now do the same thing for the next two columns. Add them all up. Okay, so I found the sums for all of my columns. Now, because we have that, let's compute the correlation coefficient. And remember, n is equal to 7. So, R is equal to 7 times the sum of x times y, which is going to be 3,568, minus the sum of x times the sum of y. The sum of x is 57. The sum of y is 495. Divided by the square root. Let's put a bracket here. Bracket is another form for parentheses. N times the sum of the square of x. So that's going to be 7 times the sum of the square of x is 579. And that's being subtracted by the sum of x, which is 57. And you're squaring that. Remember back to our measures of variation. The sum of the square of x is not the same as the sum of x, which is being squared. Not the same thing. Close that bracket and multiply it by, open a new bracket, make the fraction bar a little bit longer, 7 times the sum of the square for y, which is going to be 37,027 minus the sum of y, which is 495, and that's being squared. And close that bracket up. I know it looks like a lot, and it is, but really you will have the formula to your advantage, and to find these values here is not that bad actually. And also to find the sum is not that bad. Let's start calculating. So let's do our numerator. 7 times 3,568 minus, I'm doing the numerator all at once. And I'm following PEMDAS. 57 times 495. That equals to negative 3,239. Let's put a bigger fraction bar. Over the square root. Let's do the first bracket. And let's clear this. Well, let's just say equals. And that's going to be 7 times 579. Oops. Let's do that again. So that's going to be 7 times 579 minus, that is 57 being squared. So 57 in parentheses squared, that equals to 804. And let's do the same thing for the next bracket. That is going to be 7 times 37,027. Close that up. Minus, open parentheses, 495, which is being squared. And that equals to 14,164. Oops, I'm running out of room. So let me go over here. R is equal to, let's 39, 32, 39. Okay, let's do the square root. So second square root. Ooh, let's clear that. Second square root of 804 times 14,164. And let's take 3 numbers after the decimal. So that's going to be 3,374.590 if I round. Because I have 0.589, that 7 will make the 89 round up to a 90. And then let's divide and round the three numbers after the decimal. So negative 32.39 divided by 3374.590. And let's take three numbers after the decimal. So R is approximately equal to negative 0.960. Because that 8 makes that 59 round up to a 60. And that is our correlation coefficient. Now, we're going to use what we know about the correlation coefficient to talk about the strength of the relationship and the direction. Because we know here, the negative sign, we know that there is a negative relationship. And remember what it says here. The value of R closer to -1 will indicate a strong negative linear relationship. So the relationship between the number of absences and the final grade is a strong negative linear relationship. All right, guys. Hope this problem made sense to you. Hope you enjoyed it. Here's a screenshot. I zoomed it up, so if you want to screenshot the video, you can. And you can see the process again. Once again, this is very essential for you to know in the future how to compute this. You should know it now, but if you don't know it now, it's okay. But you need to understand the concept of what R is, indicating the strength and the direction of the relationship. All right, guys, I'll see you in the next one. Take care.